Okay, Lexi, here's the first proof from lesson 40. This is where we left off today. I'm going to do number 22 on this video recording, and then I'll do another one for 23 so that when I send them, there won't be so much to try to text to you. If for some reason I can't get the video directly texted to you, I'll set up this on a YouTube link and send you the link. But anyway, so here's lesson 40, number 22. And I'm trying to write it here. Oh, 22 right here. All right. I'm sorry, I had messages popping down too. Okay, so here we go. So let's take a look at what we have here. We have this triangle. Actually, we have two triangles kind of mashed together here. We have some given information. I'm going to go ahead and mark up the triangle according to what is given to us. So I'm looking up here at what is given, and we see that line segment MT is congruent to LT. So let's go ahead and put a tick mark on each one of those, indicating that those two sides of those triangles are congruent. We're also told that line segment OT is a bisector of angle MTL. So hopefully you're looking to see where MTL is. But MTL is this big angle right here. Right here's M, T, and L. So this is the angle we're talking about right here. So I'm going to go ahead and mark what that means to us. So if we have a bisector intersecting in an angle, it's going to cut it into two equal angles. Okay, so we kind of see where this is heading. So far, I have two triangles side by side that have two corresponding congruent parts. They have two sides that are corresponding and congruent, and there's two angles that are corresponding and congruent. So hopefully you can see what is the third thing. I can identify one more thing in our triangles that indicates that these will be congruent triangles. And notice that the reflexive property right here indicates they both share side OT. And since that is the case, we have the reflexive property here. And now we've proven we have two triangles congruent to each other. Triangle TOM is congruent to triangle TOL. Now we know something from that. When we have two equal or congruent triangles, then that means all of the corresponding parts in those triangles are also congruent. That's that whole thing we talk about, corresponding parts of congruent triangles are congruent, that CPC-TC thing we talk about. Okay, so based on that, let's go ahead and get some of this information down because that gives us a good start and a good base where we're starting. So the first thing we want to do is write down what we said was given, and that is that MT is congruent to LT. And we'll go ahead and put that OT bisects angle MTL. And that information is all given to us. Number two, based on that bisector, we now know that angle MTO is congruent to angle LTO. And the reason for that is simply because that is what an angle bisector does. So we're going to say this is the definition of an angle bisector. Okay. Number three, we indicated that OT is congruent simply to itself. Why? Because of the reflexive property. Okay, and we have all that marked up. And off to the side here, I'm going to choose a different color here for just a second. We now have a side, look here, MT and LT, and we have a side here, and we have an angle. So based on side, angle, side, now we know our triangles are congruent. And I'm going to write that next step in pink. So triangle MTO is congruent to triangle LTO. And why? Because of the shortcut side, angle, side. Okay, and remember we talked about today that we have to say those in order. So we have a side, we have an angle, and we have a side. side angle, side. Okay, now what do we need to prove next here? Number 5, let's see. Let's look at, since we now know that congruent or corresponding parts of congruent triangles are all congruent, we can pick out any of the corresponding parts to tell us, to write out another step. But what I want to take a look at is what we're trying to prove here. So take a look at that with me. We're trying to prove that OT is is perpendicular to LM. So let me mark that. What we want to figure out is how can I prove that TO is perpendicular to LM? Well, we have to have an understanding of what does it mean when something is perpendicular. If you have a perpendicular line, then that means it's coming down. In fact, this is the symbol for perpendicular, because what it does is it comes down and it makes right angles. Okay, so it looks like it's making right angles right up here, doesn't it? But we don't know that for sure. It's not marked that way, so we can't say it's true unless it's actually marked. So I'm going to get rid of all that stuff here, and we're going to go back and see what we can figure out. So, based on the side angle side, I'm going to go back and mark these sides. This was congruent to this was congruent, and my angles were also congruent to each other. Okay, that was our side angle side. And the CPCTC is what tells us all corresponding parts are congruent. If that's true, then I can say that these two are congruent, right? Those angles would be congruent. Also, look at these. These are congruent, right? Because those are congruent triangles. That means all their corresponding parts are also congruent. Okay, so we want to focus on those angles that are resting at point O. Okay, so that means that those angles in there are also congruent based on our side angle side and showing that we have congruent triangles. So I'm going to write here that angle MOT is congruent to angle LOT, and that's based on CPCTC. Okay, now let's see here. Okay, I had to take a look here at what I was trying to draw out earlier. Okay, so now let's look at angle LOT and angle MOT, which is what I just listed above. No reason. I didn't flip those around for any specific reason. I just noticed that I wrote them in the opposite order, but that's not a big deal. Okay, so let's look back at those. We also notice that these are a linear pair, right? So angle LOT and angle MOT are a linear pair. Why do I care about that? Because I also want to prove that if I have congruent triangles in a linear pair, then they both have to be 90 degrees. So for number 6, first of all, we want to say definition of a linear pair. And then in step number 7, now we can state if they're a linear pair, then that means they're equal to each other because we showed that those are corresponding angles right there. And since it's a linear pair and they're equal, they have to be 90-degree angles. So the reason for that is that if two angles in a linear pair are congruent, then each of those has to be a right angle. So if two angles in a linear pair, I'm going to do some abbreviating here, are congruent, and I'll put the little symbol for congruent, then each angle is 90 degrees. Okay, which brings us to our final step. If each angle there at this point right up here is 90 degrees, then that means that TO has to be perpendicular to, and let me flip that around because they actually state it differently in our proof statement up here. So what I have highlighted in yellow up there, I'm going to write right down here for step 8. So OT is perpendicular to LM. How did I get to that conclusion? Because perpendicular lines are lines which intersect to form right angles. And that's what I was showing you over here just a minute ago. Perpendicular lines are going to form right angles. Well, we just proved that LOT and MOT are right angles. So perpendicular, I'm going to use the symbol here. Perpendicular lines are lines that intersect to form right angles. So all those steps, deductively reasoned with our given information and working through each one of those steps and giving a reason why those statements can be true, brings us down to our proof statement. Okay, and that is the proof for number 22. I'm going to go ahead and end this particular video, and then I will send you one for 23. Alrighty? Alrighty.